Okay, so we're basically going to combine everything that we've learned so far, which is writing equations of lines, and then writing understanding parallel and perpendicular lines. So now we're going to write equations of parallel and perpendicular lines. So in our first example, basically they're saying write the equation of a line that's parallel to this line and contains the point 12, -9, which would be great if we always had a graph, but we don't. And in this case we won't, but I just want to show you what they're talking about. So basically they're asking if I have this line, y equals -5x, 5/2 x plus 3, which is this blue line here. If I have this line, and I want to know the one that's parallel to that and passes through the point 12, -9, well that would be 12, -9 about right here. What would the equation of that line be that was parallel to this? So it would have the same slope, which we learned last time, and it would pass through that point, so it would essentially look like this. But we can't tell by looking at it what the equation of that line is, and we don't always have a graph on hand. So we're going to talk about how to do it algebraically and combine everything we've learned. So what we need to know from this is, first of all, we need to know, okay, well, what should our slope be? If it's going to be parallel to this one, then they have to have the same slope. So my new slope would be -5/2. And then not only does it have to have this slope, but it also has to pass through this point, 12, -9, and it says to write it in all three forms. Well, we know the easiest one to write it in is in point slope form, so we're going to start there. Point slope form is y minus y1 equals m times x minus x1. So we're going to fill that in. We're going to fill that in with our information. y1 goes here, m goes here, and x1 goes here. And so now this is the same thing that we've been doing all along. I can clean this up and make it y plus 9, because you don't ever want to leave minus a negative. That's just not, it doesn't look right, and it's not simplified, and it's kind of hard to work with that way. And then you've got -5/2 x minus 12. So that's point slope form. That's the first one. It's the easiest one. If I want to put it in slope intercept form, all you have to do is get y by itself now. So when I go to put this in slope intercept form, I'm trying to get y by itself. So you're going to start in point slope form. And we're going to distribute first, because whenever you're solving an equation, you should always simplify both sides. When I distribute, I get -5/2 x. And when I distribute here, I get a positive 30. And then I want to get rid of plus 9, so I'm going to subtract 9 from both sides. And I get y equals -5/2 x plus 21. And that's the equation of the line in slope intercept form. Last form, like always, is standard form. Standard form, you can't have any fractions, so I'm going to start in slope intercept form. And I'm going to get rid of the denominator by multiplying everything by it. The denominator is 2, so I multiply this by 2, 2, 2, and I get 2y equals -5x plus 42. Add 5x to both sides, because standard form has the x term on the other side, and I get 5x plus 2y equals 42, and that's the third way in standard form. Okay, so now we're going to look at if it asks me to write the equation of the line that's perpendicular to one. Same kind of concept. So perpendicular, remember that has to make a 90-degree angle, but I first need to determine, well, what do I need to know from this? So I know that it's going to pass through the point 9, 5. I know the slope of this line is -3, but if they're perpendicular, if this one, the blue one, is -3/1, that's my slope, then the perpendicular slope would be the one that's the opposite reciprocal of this. So instead of negative, it would be positive, and it would be flipped. So my new slope should be positive 1/3. That's what's going to make it intersect at a 90-degree angle. So the easiest form, point slope form, we're going to start there. Y minus y1 equals m times x minus x1. And we're going to plug it in. Y1 is 5, m is positive 1/3, x is 9. Point slope form actually can't be cleaned up anymore here, so my final answer in point slope form is this, because minus is just minus. I don't have anything like minus negative or anything weird like that. My next form is going to be slope-intercept form, which is where I have to get y by itself. So I'm starting here from my point slope, and I'm going to distribute. And I get 1/3 x minus 3. Add 5 to both sides because you're trying to get y by itself. And I get y equals 1/3 x plus 2, so that's the slope-intercept form. Last one, standard form, going from slope-intercept form. Can't have any fractions, so I got to get rid of my denominator. The denominator I'm trying to get rid of this time is 3, so everything's getting multiplied by 3. And when that happens, I get 3y equals 1x plus 6. I need to move the 1x to the other side. And I get negative 1x plus 3y equals 6. And that's the equation of the line in standard form. So I went through that quickly because if you're having trouble writing the lines and rewriting them, that's where you need to look back on writing equations of lines given slope and a point, writing equations of lines given a graph. That's the part that you need to study and understand. If you're having a hard time figuring out where I got the slope from, you need to go back and watch determine parallel and perpendicular lines. This was just a combination of the two things.